Welcome to The Explainer. If you're tracking the mechanics of the global energy transition, you're absolutely in the right place. Today, we're zooming past the usual talk of carbon offsets and digging into something way more subtle but honestly, incredibly powerful. We're looking at the invisible costs that can literally make or break a wind developer's bottom line.
I mean, think about this for a second. How do you actually put a hard price tag on community frustration? We all know large-scale infrastructure causes local friction. That's a given. But how does an investor, or a corporate board for that matter, actually measure it? Well, that's exactly the mystery we're solving today. We're going to quantify those invisible forces of a wind farm, from the physical sound waves rolling off those spinning blades to the local pushback those waves create.
Here's our roadmap for today. 1. The wind industry's hidden metrics. 2. Measuring turbine noise levels. 3. The financial impact of community pushback. And 4. Why these metrics actually matter.
Okay, let's dive into this. Section 1. The wind industry's hidden metrics, translating friction into finance.
So, to understand how we track these invisible costs, we have to look at the absolute gold standard for sustainability accounting. I'm talking about the SASB standards, which are now under the International Sustainability Standards Board, or ISSB. Now, this isn't just some theoretical pie-in-the-sky guidance. These are highly specific standards that companies use to disclose sustainability-related financial info. This is the exact framework investors rely on to spot risks that could legitimately hit a company's cash flows or their cost of capital down the road.
Let's look at the actual accounting table for wind technology and project developers. Check out that highlighted row right there, ecological impacts of project development. You see, wind project approval directly hits the equipment manufacturers because, well, it dictates the demand for turbines. If a project gets bogged down by regulators or angry locals, that ripple effect hits the whole supply chain. So the SASB standards actually created quantitative metrics to track this exact risk.
Moving right along to Section 2, Measuring Turbine Noise Levels, the Physical Footprint of Sound.
So the crucial point here is how we actually measure that physical footprint. The industry relies on a very specific quantitative metric, the average A-weighted sound power level. This is measured in decibels, or dBA. And look, it's not just some guy out there with a casual decibel meter. The standards require this to be calculated using the International Electrotechnical Commission's incredibly precise acoustic noise measurement techniques. This data point is foundational because, let's face it, a turbine's noise emission is one of the absolute biggest triggers for local pushback.
And here's the thing, this acoustic data isn't just lumped together into one giant generic average. No way. The standard requires developers to meticulously categorize these sound power levels by specific wind turbine classes based on their rating. They break it all down, classes I through IV, Class S, and they even categorize further into onshore, offshore, and mixed environments. This level of granularity means an investor knows exactly what kind of acoustic footprint a company's specific product line is dumping into the environment.
Let's move to Section 3 and see how this builds. Financial impact of community pushback from noise to lost revenue. Okay, before we get to the actual dollar amounts, we need to understand the pushback itself. The SASB framework neatly buckets the risks that can literally halt a wind project in its tracks. On one side, you've got community impacts. This is your local opposition, directly related to those noise emissions we just talked about, plus things like visual aesthetics, land use fights, or safety concerns. Then on the other side, you have ecological impacts. This is the very real risk to wildlife. Habitat loss or bird and bat deaths. Honestly, either one of these categories is enough to cause a customer to totally fail to get their project permits.
And when that opposition succeeds, bam! It triggers metric RWT 410A.2. This is a hardcore quantitative financial metric reported in the company's presentation currency. It specifically tracks backlog cancellations associated with community or ecological impacts. To put that into plain English, if a local town successfully kills a wind farm development because it's too noisy or threatens a local habitat, the resulting canceled turbine orders are quantified and isolated right here on the corporate balance sheet.
And this brilliantly illustrates a very specific story of lost opportunity. It strictly counts cancellations caused by permit failures, voluntary project cancellations, or scope reductions that are directly tied to that local opposition. But it rigidly excludes your normal business hiccups, like if a cancellation is just because of some currency exchange fluctuation, or if the developer just successfully reordered turbines in the same reporting period, that doesn't count here. It perfectly isolates the exact financial damage caused by community and ecological friction.
All right, final stretch. Section 4. Why these metrics matter. The ripple effect.
So, what have we seen today?
Basically how this meticulously designed framework connects the micro to the macro. By tracking the exact decibel level of a spinning turbine, that average A-weighted sound power level, financial analysts can actually foresee the risk of these massive, costly turbine order-back cancellations. Think about it. If a company invests heavily in R&D to build quieter turbines or software to protect wildlife, they are just being nice guys. They are actually preventing these costly cancellations. They're building a massive competitive advantage to ensure their projects actually get built.
It kind of changes how you look at a wind turbine, doesn't it? It leaves us with a pretty provocative question. When we measure the true cost of green energy, is your local community's voice accurately captured on the corporate balance sheet? Well, thanks to frameworks like the SASB standards, the answer is increasingly yes. That friction, it's no longer invisible. It is a hard financial metric. Thank you so much for joining me to unpack this explainer today. Keep learning, keep questioning, and I'll catch you next time.